Hello and welcome to the Marine Biological Association's podcast, The Marine Biologist. This podcast is the accompaniment to our magazine, also called The Marine Biologist, and it explores the current issues that face our ocean. If you'd like to find out more about the Marine Biological Association or where you can get your hands on the Marine Biologist magazine, then please visit our website, www.mba.ac.uk. Enjoy the episode.
Hello, everybody. Welcome to this Marine Biologist podcast. We're delighted today to welcome Robert Blasiak, Tilde Krusberg and Lova Schildt from the Stockholm Resilience Centre. Welcome all.
Thank you.
Thank you.
We're also very pleased to be joined by the MBA's Lizzie Gibson-Hall. Hi, Lizzie.
Hi, Guy. Thank you so much for letting me co-host this podcast. I'm really excited.
Thanks, Guy. And so my name is Robert Blasiak, and so you can remember that because it rhymes with maniac. That's the way to get that one. So Blasiak, and I'm a researcher, an ocean scientist at the Stockholm Resilience Centre, where I study humanity's connection with the ocean and also how we're shaping the ocean and reshaping the ocean, how we benefit from it, and our future trajectory together into the coming years. Lova, do you want to introduce yourself?
Yes, of course. I'm currently doing a master's at the Stockholm Resilience Centre, but I have a background in marine biology where I mostly studied and worked with marine animal physiology. So here at the Stockholm Resilience Centre, I'm slowly moving away from like heavy marine biology into more of a transdisciplinary ocean futures world.
My name is Tilde. I'm also a master's student at the Stockholm Resilience Centre, and I am working with Lova on this project on marine genetic resources, marine biotechnology and marine biomimetics, and on valuation and
Thank you all. And once again, very welcome to the podcast today. We're going to be discussing the article that Robert wrote for the April edition of the Marine Biologist magazine, which is called Why Inspiration is the Ocean's Richest Untapped Resource. And it talks about biomimetics. And I think the first question really would be, can you explain what you mean by biomimetics?
Sure. Well, I wrote it, so I guess I'm to blame for it. So let me give some justification. Biomimetics, well, where to start? Basically, if you open up a dictionary and you look it up, it'll say something like biomimetics is a method for solving conceptual and design problems by mimicking or emulating the structure, the performance of organisms, and the ecosystems that shape the natural world. Something like that. It's a mouthful. But really, at its heart, it's curiosity, it's inspiration, it's a bit of dreaming. So it's about studying the world around us, trying to understand how it works, how that hummingbird flies, why that bumblebee is actually able to stay in the air, even though it doesn't look aerodynamic at all. What's happening there? And then using that to dream a little bit and think, well, maybe I'll design an airplane that's shaped like a bumblebee. Everyone thinks it's a terrible idea, but maybe there's something there. So having that little bit of crazy thinking. And then if you actually look into the details, there's a lot around the world that can be pointed to in terms of biomimetics. We've learned a lot from the natural world and we've benefited from it. So this is something I find it endlessly fascinating. And it's also been the total delight working with Lova and Tilde over these past weeks, because I've somehow convinced them that it's interesting too, but they can counter that now if they disagree.
Thank you, Robert. You touched slightly on kind of the practical application of biomimetics, but we're really interested in kind of the philosophy behind your thinking of biomimetics. So why do you choose to study it, kind of observe it, rather than look at the application side of it?
Well, I think it comes down to also a bit of wishful thinking and our kind of a philosophy of the world. So I mean, it's really easy to get a bit down and to have a bit of a bleak outlook on the world. If you look at the history of humanity's relationship with the natural world, it's a history of exploitation, overuse, degradation, all of the worst things, right? And if you look at the ocean now, you can see a lot of these exponential growth curves across multiple industries. Things like offshore wind growing exponentially, container shipping also tripling in size just in the past 20 years. And all these things growing so rapidly, simultaneously, and it just doesn't add up. It's one of the things that'll keep you awake at night if you love the ocean and you worry about the future of ocean and coastal ecosystems and the communities that depend on it. So then what do you do? What lets you sleep through the night? Well, it's you kind of grab onto hope and you think, well, maybe we've learned something. Maybe we can do things a bit better this time. For so much of humanity's history, the ocean has been kind of off limits. We haven't been able to get very far, very deep into it. We've just been kind of coasting along the surface, mostly near the coasts. But now we really can explore it in its depth. We can exploit the resources in it. And we've started doing that. But then I stumble on biomimetics, where I think, well, this is an entire sector that's kind of hidden in plain sight, that we're benefiting from the ocean, but we're benefiting in it from kind of all the best reasons. We're not destroying it. We're getting curious about it. We're learning about it. And I think that that's also the basis for caring about it. If you're interested in it, if you are studying it, if you're trying to think of new things that you can do based on what you've learned from it, then that connects you somehow to this really remote place where people don't live inside the ocean, right? So it's how do you get people to care about it? And I think that this is one way. So it's that optimist. I'm trying to keep that optimist inside alive and well. And this is one research area where I think it's possible.
Thank you, Robert. That's great to hear about optimism from researchers. It's inspiring. And why is this research so relevant now? Has it come as a result of external factors?
Well, maybe I'd just start this off and then maybe pass to Tilde and Lova, who have started talking about valuation or learning about valuation of this sector. But I would start it with talking about Norway. So Norway, one of the most kind of almost absurdly wealthy countries in the world, with literally $1 trillion sovereign wealth fund built on all the oil revenues of the past decades. Having that in the bank and having an incredibly healthy, well-educated population, having all the natural resources at their hands, and a beautiful, beautiful country. And with all of that, they decided yesterday that they're going to start mining their seabed for minerals. And this against all of the advice of their scientists within Norway, against the advice of the scientists in the high-level panel for a sustainable ocean economy, which they were co-chair of, one of the member governments of, despite everything, saying that if you mine the deep sea, you're going to irrevocably change those ecosystems and degrade them so substantially and the recovery times are so slow in the deep sea that maybe you're permanently destroying these ecosystems. And I just thought, if Norway can't say no to this, how will any country say no to this? It's a country with every card in its deck, every benefit that you could think of. So that shakes me, thinking about things like that. But then I think, well, there's that optimist that I'm trying to kind of water that plant every day, keep that optimist alive. And I think, well, but what are examples of benefits you get from those deep sea ecosystems? Because maybe those policymakers just don't care. They just think of mineral deposits. They think of nodules on the seabed. They just think of future batteries and some revenue. And who cares if some sponges are gone in the process? But with biomimetics, you have a whole kind of vein of inspiration and a whole vein of commercial applications that have arisen from being inspired by the bacteria and other things that live in the deep sea and able to develop new pharmaceuticals and new compounds that are also having strong antimicrobial properties, things like that. And there are also all of these, even like designing buildings based on the shape of glass sponges that are in the deep sea. There are so many examples. So I think, well, some things will convince some people, other things will convince other people. The people who have decided to mine the seabed of Norway, they clearly are interested in money. And if they're interested in money, you have to talk to them about value. And this is where I think, yes, we can attach some values. But this is also something I'm going to pass to you, Tilde and Lova. I don't know who wants to jump first, but tell us, what do we know about the value of biomimetics and biotechnology?
Speaking of values, I think it's important to talk about how we value nature in general before we look at specifically like how we value biomimetics, because here we have to consider, the wide range of worldviews and knowledge systems and cultures that shape our social world, which reflects how we look at nature. So it becomes very challenging to define nature's values in a universal way that is just not practical for comparison, but also representative. So we can look at instrumental values or relational values or intrinsic values. So then when we talk about biomimetics, the values that we mostly refer to are instrumental values. So we look at what monetary or life quality value does these bio-inspired innovations bring. So we can, for example, look at, anti-fouling agents, where we're mimicking these anti-fouling structure of mussel shells in cargo shipping industry, which has led to, cost and energy savings, which at the same time leads to a reduction in associated pollution and carbon emissions. Or we can look at pharmaceuticals, where we find this sponge in a coral reef, which enable us to cure HIV or cancer even. And in this case, the value would instead be like perhaps the combination of the cost of producing the compound or earnings from selling the compound, but perhaps even the value of the human or non-human life that we can save thanks to this innovation or drug that we can find in nature.
So these are there's a lot of values associated with the marine environment or marine biomimetics or marine genetic resources. And then the valuation part is really making these values explicit, right? It's about either by applying specific methodologies, we can describe, quantify, translate these values to something comparable or something that we can actually talk about and use in decision making, use as grounds for making decisions. So if we try to value, for example, the potential of finding a species or like the biodiversity in the deep oceans and trying to find a way to assess this value to make it able to have a place in decision making, as a tangible place in decision making, so that it's not just discounted when decisions about, for example, deep sea mining are made. And when we think about valuation, we often think about monetary valuation, putting a price on an ecosystem service or a specific invention. And this is quite common, I think. It's been used for terrestrial ecosystems for a long time now, but you can do it in many, many ways. According to the latest IPBES assessment, there's more than 50 methodologies for actually assessing nature's values. So there's a bunch of different things that can be done and probably should be done for different types of parts of this industry or
resources.
Yeah.
Cool. Thank you. I wonder, what is the best way to communicate the values of the ocean and the things you've mentioned and, benefit to pharmaceuticals? How do we communicate that to decision makers and governments? Is there, do you have ideas?
Some things have been popping up when we've been doing our work for the past weeks. Monetary valuation is, of course, one thing. You can look at the revenues produced from specific anti-fouling agents, for example, or energy you can save in making some kind of biomimetic architecture, production cost of medicines or a bunch of these things, right? You can actually have sizes of economic markets or structures or things like that. But you can also talk about, as Lova said, life saved from this cancer treatment that was found from deep sea creatures, for example. And this is also a value that can be used and can be incorporated. When we talk about communicating this to decision makers, these things are quite important, I think, these quantitative assessments of what can this actually give to humans and human society. But then we can also talk about, for example, relational values, perks in terms of how biomimetic inventions actually can change humans' relationships to their environments and the living world around us, which is also super interesting from a more like transformational policy view of how can we use these interventions and this way of working with biomimetics to actually change how we relate to planet Earth, or the ocean in this case.
If I could just pick up really briefly on that guy, it's really nice.
Sure, Robert.
And I mean, just to be like really specific with some of these values. One of the things that we did for the academic paper that the piece for the marine biologist was based on was to look at these marine pharmaceuticals. So FDA-approved drugs that have been derived, that have their active compounds from marine organisms. And there are about a dozen or so of these that have reached sales shelves around the world that can be bought. And I was able to find sales and revenue figures for 5 of these. And just for those 5 marine drugs over the past 10 years, there have been $12.1 billion in sales and revenue. And these are pharmaceuticals that wouldn't exist without studying the marine environment. That's over $1 billion annually in sales just from 5 drugs. And if you look at natural compounds that are the starting point for almost all of the pharmaceuticals that we use today, the rates of successful drug discovery from marine natural compounds compared with terrestrial ones is 3 to 4 times as likely. And we're finding more and more of them. So just last year, there were over 17,000 new marine natural products discovered. And focusing more on this, it seems like that could be a very valuable, lucrative area. But this is it's kind of the poster child for marine biotechnology, to point at that. And Lova and Tilde both mentioned anti-fouling. This is it's kind of the unsexy companion to marine drugs. Because if you think of anything, as soon as you put a ship in the water, stuff starts to grow on the sides of it. And to get that stuff off, all sorts of compounds are used, a lot of them highly toxic, to remove that. And if you don't remove it, then it increases your fuel costs because you have to go with all that extra drag on your vessel. So it's going to slow you down. It's going to cost more to get from point A to point B. And with over 90% of consumer goods shipped by container ships, that means a lot globally. So it's multi-billion-dollar industry for just marine coatings. So like all the paints that are put on the sides of these boats, cleaning the sides of them, it's even more. And if you're able to derive new compounds, natural compounds that are able to provide the same benefits that you get from if you think of a shark or something, that it's not covered with plankton, it's not covered with barnacles. Why is that? Well, it's the shark skin, the denticles on the shark have a microtopography that's very tough for stuff to adhere to. And some of the other species in the ocean, also like kelp, it has these special compounds on its surface that also make it very hard for other things to adhere to. And if we're able to use all of this knowledge of the microtopography of shark denticles or of these compounds from kelp and from other species, then that could be a real key to eliminating some of these most polluting anti-fouling agents, and also to making container shipping a little bit more environmentally friendly.
I was just wondering, is there any place for policymakers to understand the intrinsic value of marine life? Is that sort of thing that we take for granted? It has a value, it has an intrinsic value because we study it and we value it for those reasons. Is there any traction to be gained with policymakers from that angle?
I think, just personally looking at specifically marine biomimetics, that using or working with nature in this type of way, feeling inspired by it, can actually improve our personal relationships to nature, right? If we live in societies where buildings are designed in accordance with nature's design principles, maybe this can be a quite powerful leverage point, and where we can actually start to reimagine the nature-culture divide, the way we separate society from nature and the natural world. So I think this is really an area for improvement, and where we can work also a bit like, maybe we start using more biomimetic inventions in how we design our society, and that can itself change how we relate to nature, which can also drive more sustainable development. It can be a really powerful reinforcing feedback loop.
Yeah, and just talking about nature as, I don't know, as a mentor or a colleague rather than this pool of resources, and just keep that angle of the conversation, I think also could be a huge leverage point in policymaking.
Thank you.
And if I could just, sorry, I'm jumping in again, Guy, but if I could just add on that, I totally agree with Lova and Tilde, and I would just say politicians are people too. I know it's maybe it's a little controversial to say, but they're not a monolithic, homogenous group. They're all sorts. They're the truly evil, like profit-oriented, like that sort of almost silly exaggeration of a person. But like from that all the way to people who really care deeply about every aspect of what we're talking about. And I would say, like, one of the things that I've had the most fun with as a scientist, it happened just a couple months ago. It's a partnership with a local museum that brings school children to the museum, and they have aquariums there, and they teach them about marine life, and they walk them through the aquariums, and they explain about it. And we worked together with them to have a module on biomimetics, where we showed like different things that have been inspired by animals that live in the aquariums in the museum. And then we had a final question where they basically had to design their own biomimetic innovation, and they had to look around the aquarium. They had to pick an animal, and then explain, like, what is it? Like, is it going to be like a new robot? Is it going to be this or that? And they were amazing feedback from the students, and they drew. A lot of them drew instead of describing. These were maybe like 8 or 9-year-old students. And some of them drew like amazing, like clothing inspired by the shape of like a jellyfish or things like that. And it was just fascinating. And some of those students, maybe they grow up to be politicians. And that makes me excited to think of, I think we planted a little seed there. And I think those sorts of collaborations, they're really important. And even when they grow up and they harden and they kind of calcify into a hardcore politician, policymaker, there's still hope. Even if they're a CEO of a multi-billion-dollar corporation, there's still hope. We can rescue them. We can make them care. I truly believe it.
Yeah, what a great thing to do at school. I'd have loved to have done that when I was at school. And this question really kind of follows on from that. I mean, how would you like the world to be different as a result of your research?
I think one of the most interesting things when talking about values and valuation is to talk about how benefits from these inventions flow globally. Who actually has access to these interventions and the benefits derived from them, right? So when we start to actually assess the values, when we start doing that, either if it's monetary or non-monetary, quantitative or qualitative, we can actually start to uncover who benefits. And I think that is really important in trying to make more equitable policy, more equitable international treaties as well, in regards to benefit sharing of genetic resources or marine biomimetic inventions. I think if we are to see how value is actually created and for whom, we have to start making these values explicit. And that's kind of one of the main reasons why I think doing explicit valuation is really, really important in driving ocean equity.
And I think also, one way in which people have done that, tried to make these values explicit, is in monetary terms, as we've talked about, and by taking patents. So in this case, companies or universities or other form of corporations or organizations are actually taking out patents on gene sequences. And I think with the research that we're doing now, I'm curious to see, like, okay, who owns biodiversity? Can genetic resources be owned? Should they be owned? And in that case, by whom? Is anyone does anyone have more right to these resources than another? And here we could also talk about biopiracy, which is the practice of extracting natural genetic material and then restricting its use through patents and then exploiting them commercially, but not compensating the communities where the material was extracted from. But to sum it up and get back to the question of what we would like to see the results, or how we would like to see the results of this study, I think, just to inform international negotiation and spur transparency of how we are using marine genetic resources, and as Tilde said, the issues of access and benefit sharing of these resources, but also putting a spotlight on basic research and the value of basic research. It's funny how every time I say value now, I'm like, the value. How do we define the value in this context? But there's a value of basic research as well. And especially as Robert talked about earlier, how unexplored the deep seas are, and how much resources may be lying there for us to, cure cancer. So especially considering, this accelerating ocean economy where we're degrading this vast and largely maybe untapped genetic material resources. I think this research that we're doing could help to visualize, that there are more forms of value in the ecosystem than just rare minerals, and that additional basic research is needed to unlock or discover these values and understand these values.
Yeah, making explicit what we might be missing or what we might be losing forever through this just super focus on growing the ocean economies in an exponential speed. We are missing a lot, and we might be losing a lot of valuable resources and benefits for forever if we do this without thinking more thoroughly about the decisions we make. For example, with deep sea mining.
So what is the opportunity cost of extracting that mineral from deep sea mining?
Cool, thank you. I think interesting, while you've all been talking about the values, I wonder if within what you've talked about, if you've got some kind of preference for learning about particular extractions or examples. And this kind of leads us on to a question that's come in from one of our members of the Marine Biological Association. And they would quite like to know, what is your favorite deep sea creature and why? And I wonder if the reason for it is because of what we've been able to learn from it and extract and apply, or if it's just something completely random. So maybe Robert, should we start with you?
Oh, sure. But you ended by saying something completely random. So of course, that's where I need to go. And I think of my own kids. I talked about school kids and 8 or 9 year olds and how they we could kind of get them into this. But my own kids, they're a bit younger and they're a tougher audience. But what I told them about from this paper was plesiosaurs. The plesiosaurus. It's one of the dinosaurs. It's been extinct for 70 million years, and it kind of looked like a big whale with a long, skinny head and a little tiny head on the top, a long, skinny neck, rather, with a little head on the top. And there are people studying these. So first paleontologists reconstructing the skeletons and figuring out how they'd all fit together, but then using modeling to understand what the musculature must have been like that connected all of those bones and made them able to move through the water. And then computer models that go a step further to model how they probably did swim through the water and what their movements must have been, how the flippers and how the fins must have interacted with the water. And then the next step, the really crazy random dreaming step. Well, can we create a submersible that's like a plesiosaur? What would that look like? What would it be shaped like? And I just love that series of steps that get you to a plesiosaur submersible, or a submersible that's based on something that's been extinct for 70 million years. It's a very silly example, but if you want something a little bit less silly, pretty much the same thing happened with the snailfish. Where I forget the specific name of this snailfish species, but it was found very, very deep in the Mariana Trench. And it was described by scientists just a few years ago. And then the musculature, everything was described. And then they developed a soft robot. It was a front page story in Nature a year or two ago, the soft robot that can descend to exactly the same depths of the Mariana Trench and do research, do scientific surveys, and has the weighting of the robot. Also, it has all the electronics kind of in the head. So it's a little bit similar to the way the snailfish is. The fins are a little bit like it. It has like a little bit of a tail, kind of like it. And I just love those examples. And it's something that even really young kids, you show them a dinosaur, they'll always get interested.
Cool. I like that both of them kind of seem on a similar theme of kind of deep sea, like submarine exploration. I like your example of also thinking, because I think we've talked a lot in this podcast about how can we get, policymakers and decision makers, but actually, what you've touched on is what could be great examples to use for children to get them excited and to explain it in a way that they can visualize and understand. And yeah, Tilde, have you got something similar? Have you got another creature that's a bit different?
Yeah, I think right now I've been really into sharks, considering the anti-fouling inspiration you can find in their skin. Right now, or tomorrow, I think the Paris Summit on a new global financing pact in relation to climate change is starting, and one of the questions they're talking about is price on carbon for international shipping vessels, and price that can really, really have an impact on global shipping and how they have to actually pay for their emissions. And here, I think there's a really interesting point where these biomimetic inventions really meet, where we talk about global climate negotiations, where if these types of inventions can save a lot of energy, they will also be really important to decarbonize the shipping sector, which can then be even more incentivized soon if this actually becomes a thing. So we're hoping for that, and I'm into sharks right now for this reason.
I can continue with my favorite deep sea creature. I don't know if I have a deep favorite, but I'm a huge fan of jellyfish. I think they're, it's like aliens, and so beautiful. But another, like, coming from a fish biomimetics and locomotion perspective, I think the tripod fish, that has these elongated pelvic fins, so it kind of looks like it's standing on the seafloor, is pretty cool from like a locomotive and biomechanic perspective. And I don't know if the tripod was inspired by this fish. I doubt it. But maybe something we should look into for our research to learn.
Good way for standing on mud, maybe.
Mm-hmm.
Yeah. I was really interested in the scaly foot snail. Why has it got a scaly foot? Why does it need those scales?
Well, I can get started there, and then you should get Chong Chen on your podcast at some point, or Diva Amen, Julia Sigwart, because they've done a lot of work on the scalyfoot snail. But so the scalyfoot snail, first of all, it should have been on our list. It's one of the coolest deep sea species. It's found just on 3 hydrothermal vent systems in the Western Indian Ocean. One of them is in the EEZ of Madagascar, and 2 are in international waters. And collectively, the space that it's been found on, it would cover a few tennis courts, basically. So it's a very small space. And 2 of those hydrothermal vents fall within exploratory mining licenses that have been granted by the International Seabed Authority. So only one of them is within the national territory of a country of Madagascar. So this is a this is one of the reasons why Julia Sigwart, who's a member of the IUCN, I guess the Red List Committee, was one of the leading forces to bring this onto the list of threatened species. So it became the first, as I understand, deep sea species that was on the IUCN Red List. But it's super cool. So the reason it's immediately comes to people's minds is that it is able to biomineralize all these minerals spewing from the thermal vents. So if you hold a magnet over a scaly-foot snail, it'll start to spin, and it may even come up to the magnet if you get close. And the scaly-foot itself, as I understand it, and again, check with Chong Chen and Julia Sigwart, but there are a ton of crabs on those hydrothermal vent systems, and they're always trying to eat those poor snails. And they'll hold on to them for 2 or 3 days straight, just trying to pull them off. And so the shape of the foot is able to hold tight without getting undermined by the claws of the crab. And this is one of the reasons why it also comes up in our paper that the US Department of Defense got interested in the scaly-foot snail because the foot has like these interlocking plates. And they thought that there's potential to develop body armor for infantry troops based on the shape and the design of these interlocking plates. So that's been documented in other papers, so you can read more about it. I don't know if anyone's wearing it these days. Maybe there are scaly-foot soldiers out there somewhere, but I haven't seen any photos of that. So it may have just been a research program.
It really just remains to say thank you all very much, Robert, Lova and Tilde. It's been great having you along, and I'd like to say all the best for your research. Keep us posted. Do write for us again. And thank you very much.
Yeah, it's such a pleasure. Yeah, thank you so much, Guy. And Liza. No, I'm getting it wrong.
Lizy.
Lizy. Oh,
yeah, that's okay.
Robert or something just to get me.
Yeah, thank you, everyone.
Thank you very much for listening. This has been the Marine Biologist podcast. If you've enjoyed this episode, then please check out our other episodes. Please subscribe to our podcast. Please rate it, share it with your friends and family, and let us know what you think. And we will look forward to welcoming you to the next episode soon. Take care.